Welcome back, ladies and gentlemen. Today we're talking about making a prediction. So we're going to take this idea of how many times something has happened to be able to predict on what is possibly going to happen. So this is the idea of trying to move from experimental probability, which is recording something that did happen and seeing how many times it happened, what's the ratio in percentage and things like that, and then saying based off of that, what can we expect to happen in the future? It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So what we're looking for is we're looking at the probability of rainy days in April. Well, we're actually going to be using March to try and determine that. If it rains 2 out of the last 12 days in March, that means that 2 out of every 12 days is going to be rainy. Well, anytime we got a fraction now that we have it, it's going to be simplified. So that means 1 every 6 days. Is that actually what happened? No, it could have rained on the first day, and it could have rained on the 11th day. It could have rained on the 7th day, and it could have rained on the 12th day. Any combination to where it rained twice in 12 days. Doesn't matter when it happened, it just matters that it was 2 out of 12 days. It's the same idea as 1 out of 6. So what we can do is we know that there's 30 days in April. Look, it's even nice enough it gave us a calendar. But January, see, this is how I did it. January, February, March, April. If I'm not hitting a finger, I think it was knuckles actually is how I learned it. Sorry. January, in between knuckles, February, March, April, May, June, July, August, September, October, November, December, January, February. I know you don't see my knuckles very well, but every time I hit a knuckle, it's 31 days. January, February, March, April. I'm in between my knuckles. So what that means is there's 30 days in April. I can take this guy right here. This is our current ratio. This is our current recorded probability and in its simplest form, and we can multiply this by the number of days in April, because we want to know how many could we expect in all of April by just looking at 12 days in March. Well, if we get 1/6 times 30, it's the same thing as 1/6 times 30 over 1, because 30 over 1 is the same thing as 30. Then I'm going to multiply straight across, so I get 1 times 30 over 6 times 1. Then I'm going to get 30 over 6, which is going to be 5. So because of this, I can expect, if the trend continues, see, the funny thing about weather, it doesn't always continue, but if the trend continues, this is if I want it at the best answer possible, we can expect 5 rainy days. But you know, living in Oklahoma, that almost never happens. But hopefully you can see how we could use this to predict the total number of rainy days in all of April by looking at a small window in March. We don't need the entire time of March. We don't need to know what happened last year. We don't need to know how many butterflies or kangaroos there are in Australia and Japan. We don't need any of that. We just need to know that 2 out of 12 days in March had rainy days. Therefore, 1 out of 6 is the same ratio when simplified. And we can use that to figure out that we can expect 5 days. We could be off, we could be right on, it doesn't matter. We could expect 5 days. Pretty reasonable. Please make sure that you're taking any notes and you write down any questions that you might have due to this lesson. Work on 8.4.4 problems tonight or come in tomorrow to start working on them. And we will be able to work together, get this figured out, because this one is what it's all about. Making a prediction based on experimental or theoretical, in this case, theoretical probability. Remember, guys, it's about the process, not the answer. Have a good day.